Hello friends, so welcome to this new series of CISSP. So our ultimate aim for this particular series is to understand the topics and the concepts in those topics, and also we need to understand about the scenarios. It means the practical implementation of these concepts which is discussed in the CISSP topics. So this new series I am preparing for the fast track CISSP, that is a Google Classroom. And for this particular Google Classroom, some of the videos I'm also putting them in the public domain. So this particular video is for the public domain, that's why I'm making it live. So in this series I'm going to cover the concepts and the related scenarios of those topics given in as per the CBK of the CISSP. So to better understand the whole CISSP, and we can say the concept of the topic and its practicality is the main theme of these particular videos. So I can say, if it means we have total 63 topics in this CISSP, whole CISSP. These 63 topics, if we are able to cover 3 topics in a day, then we are able to roughly cover in 20 days the whole CISSP. Some of the topics are very small, so we can cover more topics in some particular days, but my try is to maximum cover 3 topics in a particular day. So in this fast track series, we will cover the whole CISSP in 20 days with exam preparation also. So every video will be followed by related set of questions. Suppose a particular topic, whatever we have covered in the video, whether I'm going to make it live or whether I'm going to give it you on the classroom itself. So just after this particular video, you will get the related questions related to that particular topic. So my suggestion is, watch the video, then just attempt all the questions and check out what exactly your score is. Then again go through the whole video once more, and then again check out your score in that particular questions, right? So by doing so, you will maximum the understanding from your side will be very good, and then you will get you can score maximum marks within a short time duration. So that is the ultimate aim. That's why the name is fast track. It means on a fast track we are going to cover everything with practical implementation and preparation for the exam. The understanding how exactly we are going to use all these concepts practically is more important here. The reason for the same is, if you know the practical implementation of all these concepts which are covered in the CISSP exam, then it is very easy for you to understand the scenarios which they will give in the exam, because in exam you will not get any questions from any dump. You will not get any questions related to any particular previous questions. Every time they are creating their own scenarios, they are creating new questions. So that's why if you are able to understand the practical implementation of each and every concept which is they have given in the CBK, then it is very easy for you to go through the whole CISSP in a single go, right? Okay, so today in this particular live video, I'm going to cover the very first topic, right? And then rest of the 2 topics will be available in the Google Classroom. Questions related to each topic will be individually given in the Google Classroom. You can attempt the same in the fast track Google Classroom, not the normal one. That is the fast track, a separate series I have created. That's why I'm putting it here. So also all the PPTs and other resources which I'm going to show in this particular video will be available on the Google Classroom. And as we are starting this series with the domain 3, that is the security architecture and engineering, third domain of CISSP. So the first thing is we must understand what exactly security architecture means and what exactly security engineering means. So this security architecture means designing and organizing all the components, processes, services and controls which are related to security or which are related to the IT processes, and from where exactly these IT processes are coming from, where exactly these security requirements are coming from. It is also very important to understand the same, and that's what is the practical implementation of the concept. So security architecture is a concept, right? And how to implement that particular concept, that is the practicality of that particular concept which we are going to understand in this particular whole series. And security engineering is to implement the security architecture in reality. So that is a security engineering. So we can say this whole domain of this third domain of CISSP, it covers total 11 topics, and all these 11 topics we are going to cover the very first topic here in this video. Rest two topics I will just give in the Google Classroom, fast track Google Classroom. So the first topic is implement and manage engineering processes using secure design principles. As I already told you in my older videos also, it is very important for you to understand the whole topic. So the topic here is implement and manage engineering processes using secure design principle. And as a cyber security or information security professional, it is very important for you to understand what exactly these engineering processes are and from where exactly these are coming from. Then only you can say, to secure these engineering processes I can do this, and now they are secure, right? So this particular topic wants you to understand the same. It means it wants you to understand how to implement and manage the engineering processes. It wants you to understand what exactly engineering processes are using secure design principles. So the second concept which is covered in this particular topic is secure design principle. So these are the two things which we need to cover in this particular topic. So we can say whatever business we are going to, our organization going to do, in that particular business there are some business requirements. So all these business requirements, like any particular company, they want to open a e-commerce portal. So that particular e-commerce portal, it have some requirements, right? It want a portal on which we can put the ads, or we can put the products to sale. So all these are the business requirements, right? So this is a normal business requirement. So whenever any particular business is going to start, that particular business will have some business requirement. So as per those business requirement, we will get the requirement of the engineering processes. Engineering processes are those processes which will help us to implement all those business requirement or to fulfill all those business requirement. So now whenever we are going to I can say finalize the engineering process, then at that moment itself we need to secure those engineering process, because security, when we start it from the very basic level, then it is very easy to implement. Also it is less costly in comparison to adding the security later on. So whenever we are finalizing about all these engineering processes, then at that moment itself we need to secure those. But how to secure those? Now to securely implement these engineering processes, we must use some controls, security controls we can say. Now these security controls we can take out or we can just take all these security controls from some security control frameworks. And we have lots of security control framework depending on the environment of our company, depending on the law of land, we can select a particular security control, or depending on the requirement also. So we can select some security control framework, and from that particular security control framework we can say these are the number of controls which will be applicable or which we can use in our environment to secure it. Some of the security control frameworks are like ISO 27001, or we can say 27K complete, then CIS, that is also a very good source of all the control frameworks, and then FIPS, then Cloud Control Metric, CCM, then Cisco Security Control Framework. So these are some of the control frameworks from where we can take the controls, right? So we can say once we have all these security controls with us, now these security controls will finally, when we combine all these security controls together, then we will reach the architecture. Final, we can say the security architecture. So we can say the security architecture is the design that describe how the security controls, or we can say the countermeasures, are positioned. Okay. Also, it will tell us how they relate to the overall system architecture. There will be some system architecture which will also fulfill all those requirements. Now this security architecture will be related to the system architecture, and also it will tell us how and where to place the security controls. So that is what our architecture means. Now this architecture can be of different types. They can be high level architecture, low level architecture, network level architecture. So these are the different types of architectures which are available. But whenever we are implementing any particular architecture, or we are going to make any particular architecture, then these controls, they serve the main purpose here. They maintain the system quality, we can say the confidentiality, integrity and availability of the complete whole information or the systems within that particular architecture. as a security professional, we must understand that the selection of all the security controls should be based on the secure design principles. Now, what is this secure design principles? So if we go a step further, we can say all the security controls are either based on the security design principles, or they are going to implement some of the design secure design principle. So that's what secure design principles means. So we started with the engineering processes. Now I think it is very clear to you what exactly engineering processes means, and also it is clear to you from where the secure design principles are coming from. And by doing all these things, by properly selecting the control, by making a proper architecture, we can say security is a core consideration in the overall implementation of the whole design. So finally, we can say these principles will help us in the creation of the systems which are resilient to attack, but also they are easier to manage and update. So three things are there whenever we are going to implement any particular environment. Three things are there. We need to make the whole environment or the whole system resilient. Also, we need to make it very easy to manage and update. Also, we must understand that all these principles, they require some customization as per the requirement of different environment. So whenever you are going to implement any particular architecture or any particular framework in your environment, you can customize those security controls as per the requirement of your organization. We can take a example here, like the requirement of an e-commerce portal is completely separate that remote management requirement of any power station or any nuclear power plant. So these are the two different requirements, but the principle, the secure design principles for both of them will remain the same, right? So for the CISSP exam, you need to understand two sources of these principles. First one is the S&S. So the first source is the S&S paper, which is a paper for the protection of information in computer systems, and the second one is the ISO standard 19249. So this particular standard, it is a catalog of architecture and design principle for secure products, systems, and applications. Moving further, if we go in depth in the S&S paper, we found that there are total 10 principles. These 10 principles are economy of mechanism, fail-safe default, complete mediation, open design, separation of privileges, least privilege, least common mechanism, psychological acceptability, work factor, and compromise recording. So these 10 principles, these are the 10 architectural level principles for secure design, right? So these 10 principles we are using, maybe the name is different, maybe in different because in different sources the name is different, but all these 10 principles we are using in all in our day-to-day security activities. Let's go through each and every principle one by one. Okay, before that, let's have a look on the ISO 19249 also. In this, we have 5 architectural level principles and 5 design principles. So the architectural level principles are domain separation, layering, encapsulation, redundancy, and virtualization. And the 5 design principles are least privilege, attack surface minimization, centralized parameter validation, centralized general security services, preparing for error, and exceptional handling. We are going to discuss the practicality of this, and we are going to see a very live practical implementation of all these principles, how exactly we can use them, and how exactly the different governments are using them, right? So let's move out to the very first principle, that is the economy of mechanism. So this particular, as per the very first principle of the S&S paper, that is the economy of mechanism, it says make it simple and smaller, because it is very easy. If it is very simple, then it is very easy to understand for the other persons also, and whenever any security professional want to test it, want to access it, want to design it further, or want to redesign it, then it is very much easier for him to do the same. If it is smaller, then also the overall attack surface area will be less, right? Also, it is very easy to understand if it is smaller. So we can say the KISS principle, keep it simple, stupid. So that is a normal KISS principle which we use in coding also. Also we use the same in different environment. So here also the principle is same, We need to make the things simpler as much as possible. So security kernel is a very good example of the same. So this is not the exact scenario which we are going to take. We will take different scenarios here, right? So the next principle is fail-safe default. If you are going to take about fail-safe default, it means if anything fails, then that should be in the block state, right? So if any in firewall also we have the deny all rule in the last. The reason for the same is if there is no rule which is applicable to that particular traffic which is traveling through that particular firewall, then in that particular case it should be denied, right? So that is a fail-safe default principle. And it means whenever you are going to implement anything in security, you should ask a particular question which totally depend on the fail-safe default principle. It says ask why we should give or provide access to this particular resource, to this particular traffic, right? So that is the question which we should ask whenever we are going to implement security in any particular environment, right? So then moving to the third principle says complete mediation. It means every access to every object must be checked for authority, and zero trust is a perfect example on the same. And even the race condition, canonization, all these are the examples where they use the concept of the concept behind the principle of complete mediation. So as per this principle, this restricts the caching of information, and whenever required, we need to just do the whole authentication, authorization part again. So that's the complete. So the next one is the open design. In case of open design, it says it should be open for scrutiny by the whole community. It means obscurity should not be there, right? So whenever we design anything new, it should be available to the community to test, to use, and to further develop, right? If we do like that, then more people are working on the same, and in that particular case we have much more better stable system in a longer run. So open source softwares are working on this particular concept only. And even the encryption algorithm, those like AES, all these encryption, they are not obscured, they are not kept hidden from the rest of the globe. They are provided. It means the algo of all these encryptions were provided to the whole public so that they can work on that, and then they can just say that these are the loopholes which are there in this particular encryption algorithm, right? So that is open design. Then comes the separation of privilege. Whenever we are talking about this particular principle, separation of privilege, then we can say the dwell control or the separation of duty in any particular environment, whether it is a data center. In data center we have different team for a particular purpose. Particular persons are working in that particular team for that particular purpose only. So that is separation of privileges also in separation of privileges we can say dwell control. It means a same thing will be divided into two parts, and one part will be done by one person, the other part will be done by the other person, right? So it requires two or more actors or components to operate the whole thing. So if any particular like doer and checker is also a very good example of separation of privileges. The whole process is divided into two different parts. One is a doer who will do it, the other person will check and verify the same. So we can say access to any object should depend on more than one condition being satisfied. That is the concept of separation of privilege. Next one is the list privilege. So there's a difference between list privilege and separation of privilege. In separation of privilege, we are dividing the whole process into multiple parts. But in list privilege, we are not dividing any process into multiple parts. We can say whenever anyone is going to have any particular access, that should start with a minimum access, like the guest account. Whenever any particular employee will start working in any particular organization, they will start with a guest account, and then this as their position required, they will be provided that much of privileges. So we can say it should only have the right necessary to complete your task. That is the concept of the list privilege. And by default, it should be lack of access. There should not be any access in any particular environment. A very good example is the guest account. And the next one is the list common mechanism. So we can say the list common mechanism is to minimize the sharing of the component between the user. Transitive trust, and internet are very good example of list common mechanism. Next one is the psychological acceptability. If we are going to make anything more difficult, then most of the users, they are not going to accept the same, right? If we are going to make a password very complex, like 20 digits, and then at the same time we need to have five uh, alphanumeric characters, 5 numerals, and 5 special characters, like that. If you are going to make a very complex password, then what exactly the user will do? They will write down that particular password on some piece of paper or somewhere in some soft file. So in that particular case, what exactly we want to secure is by providing a secure option for them to have a very strong password, but in other way we are minimizing the security of the overall organization because they are writing down their password, right? So this principle say that we should not make the resource more difficult to access than if the security mechanism were not present, right? So try to make it easy for the user, or they will definitely try to bypass the same. That is the concept for this particular principle of psychological acceptability. So the next principle says, the next principle, that is the ninth principle, is the work factor. So this work factor is about the degree of effort required to compromise the security of any particular control. We can say comparing the whole cost of defeating security is the basic concept behind this particular principle. If any particular encryption or any particular hash, it is we require 20 days as of now to crack any particular hash or any particular encryption algorithm, then maybe in coming future we do not require that much of the effort. So that is the work factor behind that, right? So that's why if we are having a very short password like 2 3 4 digit and it is a very simple, then using the brute force attack, it is very easy for the attacker to brute force your password. But if you are using a strong password of, I can say, 8 digit, 10 digit, 12 digit, and that too in a complex form, then they require a brute force which require much more time duration, right? And in that particular case, the work factor principle comes into account. And the last principle, that is the compromise recording. Okay, so the last principle is the compromise recording. Yes, it is not possible to secure each and everything, right? So in case anything is compromised, then we must be able to record the same. We must be able to record the compromise of the same. So that's what the 10th principle, that is the compromise recording principle, says. So it says that record that a security compromise has occurred, and also we can say it is kind of a detective control, right? Like the syslog and the CCTV, all these are based on this particular 10th principle of secure architecture, right? So with this we can say we have these 10 principles: economy of mechanism, fail-safe default, complete mediation, open design, separation of privilege, list common mechanism, and psychological acceptability, work factor, and compromise recording. So with these 10 factors, the whole S&S paper is covered for that particular, but that is a very old paper, right? So where exactly we are going to implement all these, and is there any model which is currently using all these principles? Yes, there is, and we are using all of them. And one of the good example is the ISO 19249 only, because it is giving 5 architectural principles and 5 design principles. If you check out these architectural principles and design principles, you will find a complete mapping of these 10 with the mapping of the S&S paper, right? So the 5 architectural principles are domain separation, layering, encapsulation, redundancy, virtualization. And 5 design principles are list privilege, attack surface minimization, centralized parameter validation, centralized general security services, and preparing for error and exceptional handling, right? So these are the 10 principles, 5 architectural and 5 design principles given by the ISO 19249 paper. Let's have a quick view on the practical implementation of these 10 principles, architectural and design principles, in some other model also. We have seen one, ISO 19249. Let's have a understanding of this also. Let me share my screen. Okay. Okay, I think you are able to view the same. Okay, so this is a portal by NCSC, that is the National Cyber Security Center. So this National Cyber Security Center, they provided provided some document, we can say guide for the design of cyber secure systems, and they are using all these 10 principles. How? Let's see all of them one by one. First of all, this whole portal, I will just provide the link of the same in the Google Classroom, so you can easily just come to this particular page. So here they have given the secure design principles, and they are using the whole 10 principles in different categories, and the naming is different, but the principles are still the same. First, what exactly they have done, they have grouped together all the principles in 5 different groups. These different groups are: establish the context before designing a system, okay, let me show it to you. Yeah, this is the very first one, establish the context before designing a system. The second group they have created is make compromise difficult. The third group they have created is make distribution difficult. The fourth group is make compromise detection easier. And the fifth one is reduce the impact of compromise. So these are the 5 groups they have created, and in these groups they have put all the principles. They have changed the name, yes, but if you check out in detail, then you will find that each and everything is exactly same, like the first one. So this is the very first group. The very first group, it is having total 5 principles in it. This is establish the context before designing a system. So whenever we are going to design any particular system, whether we are going to I can say design a network, then first we need to understand the context of the design, right? We need to understand what exactly the requirements are, the context in which we are going to design the whole thing. So in this they have given the principles. The first principle say understand what the system is for, what is needed to operate it, and which risks are acceptable risk. So this is the very first principle which they have given, right? Then the second principle says understand the threat model for your system. Okay. The third principle says understand the role of the supplier in establishing and maintaining system security. The fourth principle says understand the system end-to-end whole. It means we need to understand about the who is going to access the data and the devices, any third-party services which we are going to use in that particular environment, any network security devices in that particular environment, copies of our data in either moving or static in that particular environment, then communication over insecure networks, then appropriate security for every iteration of our systems. The fifth principle says be clear about how you govern security risk, right? And the sixth principle says ensure there is no ambiguity about responsibility. So these are the 6 principles. Now you will say that these principles are not there in those 10 principles. No, it is there, right? Just go in depth in each and every principle, just read out the whole thing, then you will see that each and everything is also covered in those principles also. If you go to the second category, that is make compromise difficult, right? So the first one is establish the context before designing a system. Then the second one is make compromise difficult, right? If anyone tried to compromise the system, then try to make it difficult using this secure design principles. What are these? The first one is, there are total 9. The first one is external input cannot be trusted. Transform, validate or render it safely. It means whenever it is possible, just transform it, validate the external input, or you can do a safe rendering. The second says reduce the attack surface, minimize the attack surface as much as possible. Then the third one says gain confidence in crucial security control. Fourth one says protect management and operation environment from targeted attacks. Fifth one says prefer tried and tested approaches. Sixth one says all operations should be individually authorized and accounted for. Seventh says design for easy maintenance. Eighth is make it easy for administrator to manage the access control. And ninth one says make it easy for users to do the right thing. So this is the practical implementation. Whenever you are going to design, or you want to create an architecture of any particular environment, or you want to understand any particular architecture of any particular environment, or you want to secure any particular environment, then you can use these principles. Okay, the first one category, the first category is establish the context before designing a system. So you need to understand those 6 principles which are given in the first group, and according to the same you need to understand the whole context. Then the second one says make the compromise difficult. So in these 9 principles they have given, as per those 9 principles you can just make the compromise difficult, make the attacker more difficult to compromise the whole system. The third is having total 4 categories. Then make the disruption difficult. Ensure systems are resilient to both attack and failure using redundancy, using different techniques. Then design for scalability. Identify bottlenecks. Test for high load and denial of service condition. And the fourth one says identify where applicability depends on a third party and plan for the failure of that particular third party. So these are the 4 principles they have given in the fourth one. The third one. The fourth one is make compromise detection easier. So the last principle is exactly the same. That is compromise recording. So that is in that only. Collect all relevant security events and logs. Ensure simple communication flows between component. Detect malware, command and control communication. Fourth one is make monitoring independent of the system being monitored. Fifth one is make it difficult for attacker to detect security rules through external testing. Sixth one is understand normal and detect the abnormal. So that is the fourth categorization. If we go to the last one, that is reduce the impact. So when we are talking about reducing the impact, we need to, first one is use a zone or segmented network approach, which is exactly same as we can say separation of privileges or list common mechanism. Then remove unnecessary functionality, and especially where unauthorized use would be damaging, right? The third one is beware of creating a management bypass. Okay, then make it easier to recover following a compromise. And the fifth one is designed to support separation of duties. Sixth principle is about anonymizing data where it is exported to reporting tools, and do not allow arbitrary queries against your data. That is the seventh. And the eighth one is avoid unnecessary cache of data. So these are the total principles which are given in the National Cybersecurity Center for Secure Design, which are further grouped into 5 different categories. And as a cyber security professional, you must understand this thing, that these kind of controls and these kind of documents are available via which you can understand the whole concept behind these cyber security. Right? So these 10 principles which we have discussed today, all these 10 principles are implemented in these particular document of secure design principles given by the National Cybersecurity Center. So that is a live document, live picture of implementation of these security principles, right? Okay, moving further, we can say we have one more video which is related to the next part of the same, which will cover the second topic, that is understand the fundamental concept of security models, in which I have discussed about different models like Bella Padula, Biba, Clark Wilson, and the practical implementation of these models. How exactly we are, and I've shown, in that particular video I have taken some of the practical implementation of all these models with some live classic examples as I have taken for the NCSC. And the third topic of this particular video series for today is select control based upon system security requirements. So as in any particular implementation, we have some statement of applicability, that from that particular framework we are going to take these many of controls, and these many of controls we are going to implement in our environment. So once we have the understanding of all these scenarios, then it is very easy for us, depending on the regulation, depending on some business needs, how exactly we can select the security controls and how exactly we can secure the system. So that is covered in the third topic. So these are the 3 videos which you will get today in the CISSP fast track. With each and every video you will get the questions. So just after this video, I think within next 10-15 minutes you will get the set of the questions for the very first video. Then you will get the second video, then you will get the set related to the second video, and then the third video. So in this way, keeps on preparing for your exam, and whatever doubts are there, there is a separate group for that particular users who are there in that particular fast track group. so they can just communicate with me directly if they face any particular issue related to any particular thing. If any one of you are having any doubts, then please write it down on this chat box so that I can revert to you. So I'm going to share all the resources which I have used today in my class, in my video today to you, right? With this, I just want to say thank you all.